All right, over the last couple of days, we've been looking at solving systems of equations by using graphing. Well, we knew that we would find a solution when the graphs crossed over each other at one point. That would be our solution, which is the ordered pair. Today we're going to build on that lesson and look at a new way to solve systems of equations. However, we are going to be using substitution. So we will not be graphing this time around. Instead, we are going to use substitution. So this looks the exact same as we did before. You will have equation 1. And in the first example, equation 1 says y equals 2x minus 4. Okay, and then, oh, sorry, my dog is here. And then we will have equation 2. Just like before, equation 2, this equation says 7x minus 2y equals 5. So our job is to use substitution. Well, we know that substitution is taking a letter or numbers and putting them in for a letter. So what we have is this right here. We have this equation 1. Equation 1 tells us what y equals. So we're going to take equation 1 of y equals 2x minus 4, and we're going to put it in right here for this y. Eventually, our job is going to be to solve for x. So again, same exact process. We're trying to solve for x values and for y values. But we're going to use the information that they give us to work through these equations. So I'm going to rewrite equation 2, and it says 7x minus 2y equals 5. I'm going to substitute in for y, 2x minus 4. So now when I rewrite this, I will have 7x minus 2 times 2x minus 4 equals 5. So I've used substitution. I have taken y equals this and put it in for the y. It's like a puzzle. You're just filling in the blanks with the information that you know. So now what I'm going to do is I'm going to start with the order of operations, because when I look at this, I have so many different operations. And in order to solve this, I need to have the order of operations in use. So we're going to start in the parentheses. We know that something with an x and a constant, those cannot go together. Okay, so coefficients and constants cannot go together. So instead, we're going to use the distributive property. I have negative 2 times a positive 2, which gives me negative 4x. And then I have negative 2 times negative 4, which gives me positive 8. And then again, I'm just going to drop the rest of the information down and continue to solve. Now we're going to go back to combining like terms. Things that are the same go together. So 7x minus 4x gives me 3x plus 8 equals 5. Okay, so now this right here looks like a two-step equation. We're ready to solve this as a two-step equation. Again, we want to solve for x. We want x all by itself. That is our ultimate goal. So we're going to subtract 8. That goes away. So then we have 3x equals 5 minus 8, which is negative 3. Divide by 3. X equals negative 1. Okay, so I have solved for x. I can now take x and put it into this system here, because remember, the systems work together just as though it were like a plumbing system or an electrical system. Everything has a way to work together. So we're going to take this x and substitute in back into our first equation. Okay, so we're going to take that x and we're going to substitute it in for y equals 2 times, we're going to put this negative 1 right here in there, minus 4. And now we're solving for y. So y equals 2 times negative 1, which is negative 2, minus 4. I have negative 2. I subtract 4 more. I now owe somebody 6. So my y value is negative 6. My x value is negative 1. So my solution, again, is still an ordered pair. We always use ordered pairs for systems of equations. So my ordered pair is going to be x is negative 1, y is negative 6. So if we were to graph these two equations, they are going to meet at the point negative 1, negative 6. That's where those two lines will form their x. X marks the spot. That's where the treasure is. Okay, let's do another example. Okay, so that's one example. And now I want to look at example B. So we have example B, and example B says equation 1 to our system is y equals 3x minus 4. Equation 2 says y equals, nope, it doesn't. I lied. Mistake. It says 5x minus 2y equals 10. Okay, so what we're going to do is we are going to, again, use substitution. So we can solve this without graphing by using substitution. So we're going to start with our y. We know that y right here equals 3x minus 4. So in equation 2, we're going to sub in 3x minus 4. So we have 5x minus 2 times 3x minus 4 equals 10. Again, here's my y value right here. Here's my y value from equation 1. Because they literally told me y equals 3x minus 4. So I'm subbing in for y, 3x minus 4. I'm going to cover this pink up right here so you can see that color differentiation. Okay, now we're going to solve for x. We want x's on one side. We want numbers on the other. So let's go ahead and we'll draw our line. Negative 2 times a positive 3 is negative 6x. Negative 2 times negative 4 is positive 8. These ones you have to be really careful with your positives and negatives with your multiplication. So slow and steady so you don't make those simple mistakes there. Okay, so if I had 5 and I subtract 6, I had 5, I remove 6, I now have negative 1x plus 8, that equals 10. Again, we're going to just remove 8, that gives me 2x, so negative 1, drop that down, divide by negative 1, divide by negative 1. So this tells me that I need to move my thing up. There we go. X equals 2 divided by negative 1, or negative 2. So I have solved for x. Now remember, they're a system, they work together. So we're going to take this x value and we're going to put it into the system, the equation number 1. So we used equation 2. Now we're going to use equation 1 by substituting in this x value. So we're going to, let's use a different color, 3x, y equals 3x, and x is negative 2, so 3 times negative 2 minus 4. So 3 times negative 2 is negative 6 minus 4. If I have negative 6 and I remove 4 more, I now have negative 10. So my solution to this equation is x is negative 2, y is negative 10. So these two equations graphed on a graph would meet at point negative 2, negative 10. All right, it is your turn now to do a try it. So I'm going to give you your try it. Your job is to solve the system using substitution. Okay, so you're going to solve using substitution. And this is, why do they always give you like ones that are so different in their try-its than the ones that we teach with? It makes no sense to me. All right. Okay, this one, I don't want this to mess you up, okay? It says x equals 5y plus 3. So that means you know the value of x, you don't know the value of y. So in this problem, you're going to solve for y. Okay, so sub in for x since they give you the x value. All right, go ahead and hit pause right now so that you don't hear me speaking. And then when you're ready, go ahead and hit play and we'll do our try-its together. All right, so again, x, so I'm going to sub in for x in equation 2. So it says 2 times 5y plus 3 plus 4y equals negative 1. I am now going to solve for y. 2 times 5 is 10y. 2 times 3 is 6 plus 4y equals negative 1. Combine like terms, so I have 10y and 4y. So that gives me 14y plus 6. Now I'm going to subtract 6. Subtract 6. I'm trying to solve for y here. That gives me 14y. And I have negative 7. Because I had negative 1, I removed 6. So I'm going to divide by. So y equals, I have 7 over 14. Which is negative 1/2. So now I'm going to take negative 1/2 and put it in for system number 1. So this was system 2. Now we're going to look at system 1. All right, let's plug it in. Take this negative 1/2. So it says 5 times negative 1/2 plus 3. All right, 5 times 1/2. So if I do 5 times 1/2, I get 2.5. But I also have negative in front of it. So I have negative 2.5 plus 3, which equals 3. So x equals, no, 1/2. Oh my gosh. Sorry, I didn't add. If I owe you $2.50, but I give you 3, you have 50 cents. So x equals 1/2. There we go. All right, so my x value is 1/2. My y value is negative 1/2. And so I have 1/2 and 1/2. Don't know why they like to do that to us with fractions, but they do. Okay, I think we have time for one more try it. And I think we should do one more try it just to try to get, that's not a fake. Here is your second try it. Okay, your second try it is this. it says x equals 2y plus 2. And the second equation that we're looking at is 2x minus 5y equals 1. Okay, again, hit pause so you don't hear me solving, and then hit play when you are ready. All right, so we're going to solve, put the x value in. So where I see x, I'm going to put 2y plus 2. Minus 5y equals 1. So now I'm going to distribute. So that's 4y and plus 4 minus 5y equals 1. All right, now we're going to keep solving down. So we have 4y minus 5y, which is negative 1y plus 4. I'm going to subtract 4, negative 1y. I had 1, I spent 4, so now I have negative 3. I'm going to divide by negative 1, divide by negative 1. Y equals 3. So y equals 3. So now that we know what y equals, we are going to plug y in to equation 1. So we've used equation 2. Now we have to use equation 1. So we're going to use equation 1. X equals 2y plus 2. So we're going to take y as 3. 2 times 3 plus 2. 2 times 3 is 6. Plus 2, that's 8. So x equals 8. That means that our solution is x is 8, so our x value goes first. Y is 3. So x comma y, 8, 3. All right, how did you do on this one? Okay, go ahead and tell me, explain the answer to your essential question for today. How do you solve systems of equations with substitution? And then go ahead and put your level of understanding out to the side. How are you feeling about this? How are you feeling about it in conjunction to graphing? Where are you at? And then you can either head on back to the Google Meet and ask for help if you need it, or extra practice problems, or you may head over to Big Ideas and work on your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.